Assalamualaikum. My name is Khairunmusfira Binti Alias. So today I will present for introduction. Okay, what is PNID? The piping and instrumentation diagram, which is PNID, is a drawing in the process industry. PNID show all piping including the physical sequence of branch, reducer, valve, equipment, instrumentation and control interlock. PNID also used to operate the process system because it shows the process flow piping along with the installer equipment and instrumentation. PNID is very important to the design of a particular procedure. However, they are often necessary for the management of the equipment user and for the ability to change the process they are represented. So, this is an example of image for PNID. Okay, next, we move to instrument function in PNID. So, there are a few components that use in instrument function in PNID, which is alarm, controller, indicator, sensor, recorders, and last one is transmitter. Okay, so alarm is a device responsible for the alerting plant operator about an upset condition of the process variable. Okay, next, controller. A controller is a device that receives data from a measurement instrument, compare that data to the programming set point, and if the necessary signal, a control element to take a corrective action. Okay, next, indicator. An indicator is a human reliable device that display information about the process. So next, I will pass to my team member. Thank you.
Hi, my name is Nabilah Binti Muhammad Samsuri. Okay, I will continue present my part, which is instrument function in PNID. Okay, for sensor is the primary element, which is process control loop. Okay, next, recorder, device that record the output measurement. Transmitter device that convert a reading from a sensor or transducer into a standard signal and transmit that signal to a monitor or controller. Alright, transmitter type have 5. Include first, pressure transmitter, flow transmitter, temperature transmitter, level transmitter, and lastly, analytics, oxygen, carbon monoxide, and pH transmitter. Next, we go to process involved in the PNID. That process include 4 steps, which is PFD, process flow drawing, PMS, piping material specification, EIS, equipment and instrumentation specification, FRS, functional requirement specification. Okay, for PFD, process flow drawing, PFD is a picture of the separate step of a process in a sequential order. Element that may be include are sequence of action, material or service entering or leaving the process, input or output, decision, people will become involved, time involved at each step, and or process measurement. Okay, second, piping material specification. Where find detail about material of construction, gasket, bolts and fittings. Third, equipment and instrumentation. Detail to extensive to fit into the PNID include EIS including scope, standard, code and specification, definition and terminology. Material of construction, design, basic, mechanical, fabrication, warranties, testing and inspection, documentation, and lastly shipping. Okay, for the last step of process in the PNID, which is functional requirement specification. How the plant or system operate is detailed in the FRS, include functional description, communication, and scope definition of the process. Okay, that's all from me. I will pass to my team members.
Hello, so I'm CJ. So I explain about the Alias and also the control loop. So here is our diagram for the pen ID. Output list is showing here. So we have the 21 input output, mostly are the analog input and analog output. So from here you can see that SCV100 is analog output. SCV100 is analog output because the DCS is giving signal into to the instrument. So for FT100 is analog input because the DCS is receive signal from the instrument. So for the instrument type below shown is same with the theory just now I'm saying. So if the DCS is giving signal to the instrument, so the instrument is analog output. If the DCS is receiving signal from the instrument, so it is analog input. Okay. Thank you, sir. So the type of control loop in our diagram is single variable loop. It's a feedback loop. So you can see that inside the diagram, I have configured out seven feedback loop. The first one is the controller FIC 100 go to actuator FCV 100, and after the process of chemical liquid went to output with a feedback loop of FT100 sensor. So the loop is around here. The second one is the PIC 100 controller go to the actuator PVCB 100 after the process of pressure of chemical liquid go to output and with the sensor PT 100 feedback. So it's around here. So the third one is the FIC 101 controller go to the FCV 101 actuator after the process of flow of chemical liquid go to the output with a FT 101 sensor. So it's around here, the control loop. And the fourth one is PIC 101 controller go to the PCV 101 actuator and with the FT 101 sensor. So the loop is around here. So the next is the LC 100 controller go to actuator LCV 100 after the process or level of chemical liquid with the LT 100 sensor. So the controller is around here. Okay, the last one is the PSC 103 controller go to the PSV 106, 107, 108 actuator after the process of pressure of chemical liquid go to output with a PT 103 sensor feedback. So the loop is around here.
Okay, good evening. So this is our project control builder and diagram design. So now we are going to show you the module bus.
Okay, so there is a two module bus that we're going to use. One is a AI815 and an AO801. Why we're using this is because we are using the 8 input. So these are the 8 inputs for this one AI, and this is a input for the AO. Now we go for the diagram. So there are 5 controller loop in our PID diagram. So these are the 5 control loop. So now I'm going to go online. So we are online, consider it a success. So